A very good morning, my dear students. Myself, Dr. Rupi Dheer, is welcoming you again in this series of lectures on group theory. In today's lecture, we are going to discuss about definition of a group, postulates of group, and abelian and non-abelian groups. Hope you will enjoy the lecture. Let's start. In previous lectures, we have already discussed all about the symmetry elements, symmetry operations, their types, and all the symmetry elements present in these 5 molecules with different geometries. For example, we have discussed in water molecule having bent geometry, there are 4 symmetry elements: identity, C2, sigma V1 and sigma V2. Means there is a collection of symmetry elements. These collection of symmetry elements are regarded as a group, but these elements must follow certain conditions to be a part of group. And in this lecture, we are going to discuss all about group. First of all, definition of a group. What is a group? A group is a collection of symmetry elements, but these symmetry elements or these collection must follow certain conditions which are known as the properties of group or postulates of a group. So, I again repeat, what is a group? It is a collection of elements, symmetry elements which are bound by certain conditions known as properties or postulates of groups. And there are 4 postulates. First one, the group contains an identity. Second, the group contains inverses. Next one, the operation is associative, and the last one, the group is closed under the operation. Now, we will discuss these 4 postulates one by one in detail. Very first postulate is the identity. Now, this identity is denoted by capital E, and this element must be the part of each and every group. And when this element is combined with other elements of the group, it leaves them unchanged. For example, let's A, B, C and D are the elements of the group, and when A is combined with identity, the result is again A. For example, let's take in water molecule. Water molecule C2 is a member of the group. So, whenever E is combined with C2, the result is C2. If it is combined with sigma V, the result is sigma V. So, identity is denoted by E, and it must be the member of each and every group, and it when combines with other elements, it leaves them unchanged. Hope identity is clear to all of you. Second postulate is inverse. Again, every element in the group must have an inverse, and when the element is treated with its inverse, the result is identity. For example, again, in water molecule, if C2 is the element of the group, then there must be its inverse, that is C2 inverse, and whenever element is combined with its inverse, if C2 is combined with C2 inverse, the result is identity. So these are the first 2 postulates of the group. First one is identity denoted by capital E. Second one is inverse, and there must be an inverse of each and every element. Third is associative property, which now the associative property says that combination of 2 elements must be associative, which means if A, B, C are the elements of the group and A is treated with the combination of B and C, it must be equal to the combination of A and B treated with C, or again the A multiplied by B multiplied by C. But there is one condition, there should not be any change in the order of the group. Means always A comes first, then B, then C. And last one is the closure property. According to closure property, result of combination of 2 or more elements or the square of any 2 elements in the group results in the member of the group, which means if we multiply any two elements of a group, then the result must be the member of the group. Means any combination, multiplication, addition, subtraction, the result should be the member of the group. It is known as closure property. So these are the four postulates of the group. I again repeat. First one is identity. Second one is inverse. Next one is associative. And the fourth one is closure. Identity is denoted by capital E, which leaves all the elements unchanged. And inverse means every element has an inverse, and when element is treated with its inverse, result is identity. Associative means again A treated with association of B and C is equal to the combination of A and B treated with C, provided order remains same. And last one is the closure, which means if we combine any two elements, then their result must also be the member of the group. So again, a group is a collection of symmetry elements that must follow these four postulates. Next is the types of group. The groups are divided into two main types, that is abelian and non-abelian groups. First one is the abelian group. Now, an abelian group is that group in which all elements, when combined in either way, give the same result. Or in other words, elements must commute with each other. For example, in water molecule, whenever a C2 symmetry operation is carried on a molecule followed by sigma V, and if we reverse the order, means first sigma V is performed, then C2, there would not be change in the result. If the result is same, this means this group is a abelian group. Now, here I have shown these two combinations. In the first one, firstly C2 symmetry operation is performed, in which an axis passed through the center of oxygen and both the hydrogens will change their position as shown. H2 has substituted H1 and H1 has substituted H2. Then a plane is passed through the center of oxygen. Again both the hydrogens will change their position. Now in the second case, first sigma V is performed and then sigma 2 is performed, C2 is performed. But the result or the final configuration remains same as shown in the pic. Hence, these elements in water molecules commute with each other, and thus water molecule is an example of abelian group. And if this is not equivalent, then that group is known as non-abelian group. For example, if all the elements don't commute, then the group is known as non-abelian group. Let's take the example of ammonia molecule. In ammonia molecule, the result of the combination of C3 with sigma V1 is not equal to if the order reverses. For example, firstly in C3 symmetry operation, an axis is passed through the center of nitrogen and all the three hydrogens are changing their position. Now you can clearly see here H1, this H1 is at this position in after C3 symmetry operation. Here it is H2, here it is H3. After that, sigma V1 operation is symmetry operation is performed. Sigma V1 means a plane is passed that involve one nitrogen and one hydrogen. This one here is the plane because first position is according to the position of H1 in the starting molecule. So now this nitrogen and hydrogen will remain at their positions and H1, H2 are substituting their position. Now in case 2, the order is reversed. First sigma V1 is performed. In sigma V1, nitrogen and H1 are not changing their position, whereas H2 and H3 are reflecting here. And in C3 symmetry operation, an axis is passed through the center of nitrogen. All the three hydrogens are changing their position. This way H1 is at here, here comes H3 and here H2. Now if we are comparing this one structure with this one, these two are not identical structures. Means this combination is not followed. So hence ammonia represents a non-abelian group. Hope this